Good evening, students. So today we are going to discuss with atoms chapter. Okay. So directly I'm going to start with the questions. Yes. Okay. So see here, the first question is solar spectrum is an example for. So here the solar spectrum is the example for band absorption spectrum, line absorption spectrum, line emission spectrum, continuous emission spectrum. Okay. So here you may not study these in theories, but these are little application based on the spectrum concept. Okay. So here you just need to remember some of the points. Here the solar spectrum, what we are observing, it is the example for, remember, it is the example for the line absorption spectrum. Okay, that is Fraunhofer lines observed in the solar spectrum are absorption lines suspended sus- superimposed on the continuous spectrum. So this is the example for what, that is line absorption spectrum, remember. Okay, so solar spectrum are the example for the line emission spectrum. Going for the next question, students. See here, the next question is the ratio of minimum wavelength of Lyman and the Balmer series will be. So here we will have the, as you know that we have five series like Lyman series, Balmer series, Paschen series, Brackett series, Pfund series. Okay, so here they are asking the ratio of the minimum wavelength of the Lyman and the Balmer series. Okay, here to calculate the minimum wavelength, always you remember when they say the minimum wavelength anta ಹೇಳಿದಾಗ, the value of n2 will be infinity. So we will have actually n1 and n2. So ಅದರಲ್ಲಿ n2 value infinity ಆಗತ್ತೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. For minimum wavelength calculation, the n2 value will be, that is infinity. n1 value will be with respect to ಯಾವ series ಮಾಡ್ತಾ ಇದ್ದೀರಾ. Okay, so for example, if you are taking Lyman series, n1 is equal to 1. If you are taking the Balmer series, n1 is equal to 2. Like that you need to consider. Okay, so here the minimum wavelength of the highest, for the highest energy is given by n1 is equal to 1 and n2 is equal to, it will be infinity. So in that case it will be what, that is the value will be, it is E naught. So for the first one, that is for the Lyman series, the energy will be E naught. Similarly, for the Balmer series. So Balmer series, the N1 value will be 2 and the N2 value will be infinity. So initial energy is E naught. Therefore, here what happens? That is E naught divided by 4. The formula, hope so you know, it is E divided by N square. Okay, it is E divided by N square. Here E naught is considered as the energy in the question. So n square means here in the above case it is 1 square, here it is 2 square, that will be 4. Right. So the Balmer series has 4 times the wavelength. The Balmer series has the 4 times the wavelength. Therefore, here if you take the ratio of these energies, if you take the ratio of these energies, it will be 1 divided by 4. So here options are given like 5, 10, 1.25, 0.25, like that it is given. So 1 by 4 and you simplify madidre, it will be a 0.25. It will be 0.25. If any doubt is there in this question, you can ask. Here they are asking the ratio of the minimum wavelength. So when they say minimum wavelength, it will be n2 is equal to infinity. Okay, so next question. Hydrogen atom does not emit X-rays because. Yes, can you guess this answer? Yes, hydrogen atom does not emit X-rays because option C, it contains only a single electron. It is very small in size, energy levels, it is very are very close to each other. Energy levels in it are apart. Yes. So here the option will be, that is why that is hydrogen atom does not contain the X-rays, because of the option C. It has only single electron. It has only single electron. See the next question. in ruby laser, the stimulated emission is due to transition from. Here they are asking in the question, that is, in ruby laser, the stimulated emission is due to transition from. So here this is also little JE or NEET based question. Okay, so CETL it baralla, because stimulated emission you will not study in the state board syllabus. So here the state board, the stimulated emission is due to the transition from. So you can note down this, that is option C, that is metastable state to the ground state. Okay, so here it is because of the metastable state. So metastable state is the intermediate state. Okay, so ground state, metastable state, higher state, like that it will be there. So here in the ruby laser, the stimulated emission occurs because of the transitions from metastable state to the ground state. Okay, so here you can see the ruby laser is a 3 level laser. Here the stimulated emission is due to the transition from the metastable state to the ground state. The next question, the spectral series of the hydrogen atom that lies in the visible region of the electromagnetic spectrum. Yes, here see the spectral series of the hydrogen atom that lies in the visible region of the electromagnetic spectrum. That is option A, Paschen, option B, Balmer, option C, Lyman, option D, Brackett. Visible regional yaud baratte. So you have the 5 series, out of 5 series which will come. Option B, Balmer. Yes, correct answer. The Balmer series will come in the visible region. Yes, next question, students. Continuous emission spectrum is produced by. So continuous emission spectrums are produced by mercury vapor lamp, sodium vapor lamp, the sun incandescent electric lamp. Yes. Yes, continuous emission spectrum is produced by, that is option A, that is due to the electric lamp. Okay, it is due to the electric lamp. So here, that is the electric lamp gives continuous emission spectrum. Mercury and sodium vapor lamp gives the line emission spectrum. You can note down these points. That is, lamp gives continuous emission spectrum. Mercury and sodium vapor lamp gives line emission spectrum. The Fraunhofer lines seen in the sun's spectrum constitute an absorption spectrum. The main body of the sun emits continuous spectrum, whereas the cooler vapor in the sun's atmosphere emits the line spectra corresponding to the elements present. So you can just make the points of this. ಬೇರೆ ಬೇರೆ ಕ್ವಶನ್ ಬೇರೆ ಬೇರೆ ರೀತಿಯಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಲ್ಯಾಂಪ್ ಕಂಟಿನ್ಯೂಸ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಕೊಡುತ್ತೆ. ಮರ್ಕ್ಯೂರಿ ಸೋಡಿಯಂ ಲ್ಯಾಂಪ್ ಗಿವ್ಸ್ ದಿ ಲೈನ್ ಎಮಿಷನ್ ಸ್ಪೆಕ್ಟ್ರಮ್. So you can copy down these points. Yes, completed, students. Okay, going for the next question. See, hydrogen atom from excited state comes to the ground state by emitting a photon of wavelength lambda. So here, that is the hydrogen atom from the excited state, it comes to the ground state by emitting photon. So hope so you know what you mean by the photon. Photons are nothing but the small packet of energy. The energy is given as E is equal to h nu. Okay, so hydrogen atom from excited state comes to the ground state by emitting a photon of wavelength lambda. Here, if R is the Rydberg constant, the principal quantum number n of the excited state is, yes, here R is the Rydberg constant. The principal quantum number n of the excited state is. So here we need to write the expression for the principle of quantum number. You can see here how to do this one here, students. So according to Rydberg's formula, the expression is given as 1 by lambda is equal to R into bracket 1 upon nf square, that is final minus the initial. So minus 1 upon ni square. So nf is 1, ni will be n. As they have specified, it takes the transition from excited states to the ground state. So therefore, excited state will be ni will be n, and the ground state value will be nf is equal to 1. So substitute, see here. So according to the simplification, it is 1 by lambda is equal to R into bracket. So nf value is 1 square minus 1 upon n square. So 1 square will be 1 by n square. Therefore, it is R into bracket 1 minus 1 upon n square. That is 1 by lambda is equal to. So lambda R is equal to, which is equal to lambda into R into bracket 1 minus 1 by n square. Okay, so here we can just transfer this one. It will be 1 divided by lambda into R, 1 by lambda into R, which is equal to 1 minus 1 by n square. So we just want the value of the n. So what we can do? Now we can shift this one. So 1 by n square we can transfer, which will be equal to 1 minus 1 upon lambda into R. Okay, so we require only n value. So what we can do, reciprocal ಮಾಡ್ಕೊಳ್ಳಿ. So reciprocal ಮಾಡಿದ್ರೆ, if you take the LCM, it will be lambda R divided by lambda R minus 1. As it is n square is equal to n is equal to ಏನಾಗುತ್ತೆ under root it will be. Yes, very, very important point. Important question. Important concept. So you can copy down this. If you want question once again, I'll display the question once again. So copy down the solution. Is the next question. The spectrum of an oil flame is an example for the spectrum of an oil flame is an example. So oil flame do spectrum yadike example agatte, that is line emission spectrum, continuous emission spectrum, line absorption spectrum, band emission spectrum. So it will be option B, that is it is the continuous emission spectrum. So we have discussed so many different spectrum for the different rays. So you can just copy down these points. Okay, the next question here, students. An electron is moving in an orbit of hydrogen atom from which there can be a maximum of 6 transitions. An electron is moving in an orbit of another hydrogen atom from which there can be maximum of 3 transitions. The ratio of the velocity of the electron in these two orbits is. Yes. So here the electron is moving in an orbit of hydrogen atom from which there can be a maximum of 6 transitions. Okay, so it is in one orbit where you can have the 6 transitions. An electron is moving in an orbit of another hydrogen atom where it can have the maximum of 3 transitions. The ratio of the velocity of the electron in these two orbits is. See, how to calculate the number of spectral lines here. See, the number of spectral lines obtained due to the transition of electron from nth orbit to the lower orbit is, that is n is equal to, so n, capital N indicates the number of the spectral lines. So that n is equal to n into bracket n minus 1 divided by 2. So here the small n will be how many transitions it can have. So in the first case, it is having the 6 transitions. So capital N is the number of transitions. So that is capital N. The value in the first case is kottidare. In the first case, the value is 6. So this is 6 is equal to n into bracket n minus 1 divided by 2. So here if you simplify the value of n, it will be n is equal to 4. Similarly, in the second case, the transitions are 3 here. Therefore, 3 is equal to n into bracket n minus 1 divided by 2. So therefore, n is equal to, it will be 3. But here they are asking, so question alone calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. In the question they are asking the ratio of the velocity of the electron in these two orbit is. So here the velocity of the electron in the nth orbit is given as, you can copy down this, that is 2 pi e square upon 4 pi epsilon naught nh, that is the velocity in the nth orbit. So here if you see the formula, so formula ನೋಡಿದಾಗ ಎಲ್ಲ values constant ಇದೆ. The velocity formula is constant for, like 2 is constant, pi is constant, e is charge of the electron is constant, 4 pi epsilon naught h, everything is constant. So what we can say, the velocity is inversely proportional to the value of the n here, right? So here, as they are asking the ratio of the velocities, so velocity of the 6 transitions to the velocity of the 3 transitions is equal to, so it is inversely proportional irodrinda, it will be 3 divided by 4. Option D is the answer. Okay, let us go for the next question. See the next question here, students. V1, nu 1 is the frequency of the series limit of Lyman series. Okay, so here the frequency of the Lyman series is given as nu 1, and nu 2 is the frequency of the first line of Lyman series, and nu 3 is the frequency of the series limit of the Balmer series. Then here the relation between the frequencies they are asking. So nu 1 is the frequency limit for Lyman. Nu 2 is the first line of the Lyman series. Nu 3 is the frequency of the series limit of the Balmer series. Yes, see. Here, the relation between these velocities, we can write it as, here we have the formula for velocity, that is not velocity, sorry, frequency. So the frequency nu is equal to R into C into bracket 1 upon n1 square minus 1 upon n2 square. Okay, so here where n is equal to, so here as it is specified that N1 will be 1 for the Lyman series, N2 will be starting from 2. Howda? So hagagi first again new one anta kottidare. For that frequency, if you do it, so here in that case, for the series limit of Lyman series, so they have specified that series limit. So this also you remember when they say series limit, matte minimum frequency andaga, the value of N2 will be infinity and the value of N1 is for the Lyman series is 1. Therefore, it is nu 1 is equal to RC into bracket 1 by 1 square minus 1 upon infinity square. So therefore, this is equal to RC. Okay. So similarly, the nu 2 frequency first line of the Lyman series is given as N2 is equal to 2. Therefore, it is nu 2 is equal to RC into bracket 1 divided by 1 square minus 1 upon 2 square. So, which is equal to 3 divided by 4 RC. So, similarly, for the Balmer series, it is given as nu 3 is equal to, so for the Balmer series, it will be how much? So, the value of N1 will be 2 square minus series limit anta helidare, so that will be also infinity. Therefore, here if you simplify, we will get equation 3 as RC by 4. So here you can see equation 1, equation 2, equation 3. So if you see all the three equations, so the nu 1 value, the first frequency is RC, the second frequency is 3 by 4 RC, the third frequency is that is RC divided by 4. Correct. So if you see the value, what you can judge here, either you can say nu 1 is equal to nu 2 plus nu 3 and the L2 sum will be a nu 1 first frequency, or the difference of first and the second frequency will be the third one. So therefore we can go for option A. So option B they have not given in the question. So we can go with option A, that is the difference of the frequency is equal to the third frequency. Copy down. Is the next question. The de Broglie wavelength of the electron in the ground state of the hydrogen atom is? Yes, very simple question. Yes. Yes, what is the answer for this? The de Broglie wavelength of the electron in the ground state of the electron atom is? See here, that is according to Bohr's quantization condition, that is according to Bohr's theory, that is the angular momentum is equal to integral multiple of h upon 2 pi. So therefore, here if you simplify this formula, h by mv is equal to, we can write it as 2 pi r by n. So therefore, de Broglie wavelength will be h upon mv. So equating equation 1 and 2, we will get 2 pi r by n. So for the first orbit, r is equal to 0.53 and n is equal to 1. So therefore, lambda is equal to, if you substitute, it will be 3.33. Option B is the answer. Okay. Yes. Next theory-based question. Rutherford's atomic model could account for stability of atoms, origin of spectra, the positively charged central core of an atom, concept of stationary orbits. Rutherford's atomic model could account for. Yes, option C. Correct. So according to Rutherford's atomic model, the entire positive charge and most of the mass of the atom is concentrated in a small volume that is called as the nucleus, and the electrons are revolving around it. Next question. When an electron jumps from the orbit n is equal to 2 to n is equal to 4, then wavelength of the radiation absorbed will be, R is the Rydberg constant. So let us see how to calculate this one. Here the values of n is equal to 2, n is equal to 4 it is given. Transition n is equal to 2 to 4 anta kottidare. So very simple, you can just substitute in the Rydberg's formula. You can check out this very simple simplification. Yes, 1 by lambda is equal to r into bracket 1 by n1 square minus 1 by n2 square. So simplification, you can see it will be 16 by 3r. So ಇಲ್ಲಿ ಏನು wrong ಮಾಡೋ chances ಇರುತ್ತೆ ಅಂದ್ರೆ, you will get 1 by lambda is equal to 3r by 16. So if you don't reciprocal, you will write the wrong answer, correct? So please write it properly. The ratio of minimum wavelength of Lyman and Balmer series will be. Yes, this one I think already we have calculated. So leave this. See this. If n is the orbit number of the electron in a hydrogen atom, the correct statement among the following is. So here n is the orbit number of the electron in a hydrogen atom. Right. The correct statement among the following. Electron energy increases as n increases. Hydrogen emits infrared rays for the electron transition from n is equal to infinity to n is equal to 1. Electron energy is 0 for n is equal to 1 and it varies as n square. Yes. Yes, option A is the right answer. Okay. Next question you see, in a ruby laser, the color of laser light is due to. So if you see the ruby laser, it will be red in color. So it is because of the color of the laser light is due to oxygen, aluminium, silicon, chromium. Yes, it is option D. It is because of the chromium atom. Spectrum of sunlight is an example. This is already discussed. Yes, this one you see. The ratio of the magnetic dipole moment of the angular momentum of the electron in the first orbit of hydrogen atom is, here the ratio of the magnetic dipole moment to the angular momentum of the electron in the first orbit of the hydrogen atom. See, the magnetic dipole momentum for the electron is given as m is equal to eh upon 4 pi m. And the angular momentum of the electron in the first orbit is L is equal to h upon 2 pi. So divide 1 by 2. So if you divide the angular momentum by the magnetic dipole moment by the angular moment, you can see it will be E divided by 2m, E by 2m. Okay. So the last question from the atoms chapter, pick out the wrong statement. Pick out the statement from the following. Correct statement. Okay. So see, mercury vapor lamp produces line emission spectrum. Oil flame lamp, line emission spectrum. Band spectrum helps us to study molecular structure. Sunlight spectrum is an example for the absorption spectrum. Yes. Correct statement you need to identify. So here statement A, B, D, A, C, D are the correct statement. B is the incorrect statement. So this is sometimes two or three answers will be right. So this is also a little bit JE based question pattern you can say. Okay, so CET ಅಲ್ಲಿ ಈ ತರ chances ಇರೋದು ಕಡಿಮೆ ಆಯ್ತಾ. So this completes atoms chapter students. Next class we can go with nuclei topic. So nuclei ಇದೆ. We need to go for semiconductors, then wave optics, dual nature of matter and radiation. So next class we will see some part of nuclei questions and we will start with dual nature of matter and radiation. Adadmele wave optics and the semiconductors we will discuss. So by November 30 we will be completing the KCET program. Then we will start with the revision. Okay. So if any doubt is there you can ask, otherwise we will meet in the next class. Yes, thank you. Bye.